Hi, good morning, good afternoon, wherever you are today. Thank you for joining this session on how to integrate OPC technology with Catena X in order to provide collaborative data exchange across the value chain. My name is Thomas Obermeyer, and I'm the lead data space architect of the Catena X Automotive Association. Today, I'd like to talk to you about three major aspects of the data exchange in the automotive value chain. So first, what is Catena X and what is its value proposition? Second, what are the technical building blocks of Catena X? And last but not least, how can we technically combine the power of OPC with the data space approach of Catena to address today's business challenges? When we look at the automotive industry over the years, we are facing some real serious challenges. Regulatory requirements from all over the world pop up. A fierce competition and geopolitical dependencies along all parties to reduce costs across the value chain. At the same time, we all know that supply chains are global and heavily intertwined. Resiliency, of course, across the supply chain is an absolute must. We've seen that at least with the latest pandemic that we had. So we came to the realization that automotive business processes need an existential update. We believe that companies need to radically collaborate to address today's complex business challenges. A single company cannot do that alone anymore. That's why we, in 2020, 2021, initiated Catena X. It has started as a consortium of 28 partners. At the beginning, it was partially funded by the German government, but has since then expanded into a larger ecosystem. Catena X enables sovereign data exchange across the entire value chain, from OEM and suppliers to mid-sized companies. All participants retain full control over their data at all times. The goal of Catena X is to sustainably enhance transparency, efficiency, and resiliency across the industry through shared standards. So what are our design principles? First of all, as you can see here, we want to have full industry representation. So we have OEMs, we have suppliers, we have SMEs and research organizations being part of Catena X, but also solution and service providers are participating and shaping the ecosystem. So for us, it's important that we have a collaboration on eye level. But we realized really early that just starting such an initiative in Germany or even in Europe is not enough. So we, by now, really have a global representation. We initiated hubs across the globe from the US, in Europe, like France, Spain, but also into Asia, Asia Pacific, like Japan and China. So these local hubs are also helping us to establish the ecosystem. But we didn't stop at the industry boundary, because many automotive suppliers are also suppliers in other industries. Therefore, it's so important that we really look at cross-industry initiatives. Therefore, we are collaborating with cross-industry initiatives like Manufacturing X, Factory X, Aerospace, or Semiconductor X, because at the end of the day, we need to provide interoperability for participants that are utilizing different data spaces. So ultimately, the purpose of Catena X is to provide a trusted and interoperable data exchange network from the industry for the industry. So we already mentioned the flood of regulatory requirements that is upcoming. And if we look at just the sustainability domain alone, there's various regulations in effect or in planning that will impact most supply chain participants. Let me just point out a few of those. So looking at recycling of batteries in used electric vehicles or critical material declaration. We have the German Supply Chain Act or the critical raw materials and energy-related products. Product carbon footprint, scope 1, 2, 3 calculations, that's on everybody's mind. Or we have also very prominently the European Digital Product Passport. And this Digital Product Passport alone requires around 107 data points, with 52 data points reflect primary data. That's from our perspective, quite a lot of data for a single use case. Let's zoom into this use case of the EU battery passport just for a little bit, because it's one of the most relevant product passports. It comes into effect in 2027, as most of you know, I assume. So we can easily see on the diagram here that the upstream and the downstream value chains of an electric vehicle, they are both quite diverse. And if you look at the left-hand side on the attributes and categories, you see also various categories from battery materials and compositions over compliance, labels, certifications, up to performance and durability indicators at the bottom. So the data points that are being collected along the supply chain, most often they need to be handed over to other participants in the process chain. So they start to become into existence in the early stage, but they are usually required at a later stage as well. So Catena X provides technology components and use case standards to provide trusted and data sovereign data exchange in a multi-tier process where the sensitive, verified, and massive amount of data sets need to be shared. So product data, the product path is a prime example for that. But how do we do that? On this slide, we have outlined a bit the most relevant technical building blocks as of today that Catena X has implemented. Important to mention is that one of the guiding principles of Catena X is to provide data in a very decentralized fashion. So data is not stored in a central intermediary or a central data lake, but it's being kept at all times under the control of the data owner. So let's start at the very bottom of this diagram and move our way up. Our foundation at the very bottom of trusted data exchange are the two building blocks we see at the bottom. So we see the decentralized claims protocol and the data space protocol. The decentralized claims protocol allows us to implement self-sovereign identities, also decentralized, based on W3C standards. And here we're using extensively also verifiable credentials as a means to model those identities. On the right-hand side, you see the data space protocol. The data space protocol was originally developed by the International Data Space Association, and it's now being governed by the Eclipse Data Space Working Group. It's also going to become an official standard soon. But the data space protocol really helps us to define usage policies, to also make sure that we can model rules for data access and attach those rules to data. And here we're using the Open Rights Digital Language, ODIL, as a way of modeling those usage and access rights. Moving up to the second layer from the bottom, you see the asset administration shell. The asset administration shell provides the standardized data access of data provisioning of digital twins. So here we are using also a framework governed by the IDTA to allow unified access to data. Those two layers pretty much represent more the technical interoperability layers of Catena X. If we now move a little bit higher up, we will see also the semantic interoperability. And here we see two aspects. We see the aspect of industry core and the specific use case data models. So on the industry core, we are pretty much modeling and designing all the use case agnostic aspects that we need, right? So like a bill of material models or life cycle aspects, things that we want to use and reuse across use cases. On the right-hand side, you see more the use case specific data models like fleet data for quality data use case, or a business partner certificate for a certificate use case. So those are specific data models for particular use cases, as I said. And then besides just providing standards for interoperability, we also strongly believe in open source and in reference implementations, which we are developing in the Eclipse Tractus X project. So all of our standards are also implemented in open source, and reference implementations are being provided. What we got as feedback from our community is that reference implementations are great, but sometimes they need more explanations, right? They need white papers, they need APIs, they need additional documentations. So we bundle all of those artifacts together with the source code together in something we call the kits, keep it together. And these kits are the basis for every solution provider to develop functionality on top of Catena X. Again, the kits, as I said, are also available open source. But what we are seeing here, we have a lot of great assets, but what we haven't seen is access to live data, right? To actual live data. And that's something we haven't really focused on too much in the past. But when we remember the battery pass example, right, with the 107 data points and the various actors in the supply chain, I mean, how do we address that in Catena X? So essentially, we are chaining data assets, as you can see here, together across the value chains from step to step to step by means of connector technologies. So connectors that are talking this data space protocol and the decentralized claims protocol. So via this technology, we can provide sovereign data exchange between trusted business entities. But besides this classical data assets, right, like maybe a battery ID or a manufacturer name or a manufacturing date that needs to be passed on, the digital product passport also requires live asset data like energy consumption from production facilities. Because otherwise, I mean, we couldn't report scope 2 emissions, indirect emissions, right? So here we really see that, or we really believe that we now get additional great value out of the combined integration between the different frameworks that we see on the slides. So if we talk about energy consumption and production carbon footprint, so scope 2 emissions, OPC UA could provide energy consumption data or energy usage data from machines and sensors to support carbon footprint lifecycle asset assessment tools. So, or I mean, if you look at the battery performance and durability case, OPC UA could also connect to test benches or to battery management system simulators to provide that kind of data into the overall product path and the overall process here. So all of these data points are extremely important for the battery path, and they are currently not available in our existing Catena X integration scenarios. And that is where we believe that OPC and Catena X can complement each other. So OPC UA provides real-time production and process data, for example, energy use or quality metrics or safety events. Catena focuses on lifecycle and compliance data exchange, like for material origin, for carbon footprint, or for recycling information. And if we combine this, they can really ensure that both operational and contextual data required by the battery pass are available and verifiable. So a very, very good value proposition from our perspectives. So I guess, I mean, the why is pretty clear. So let's talk a little bit about the how and how we bring the integration together. And this diagram you might already be familiar with, as it's originating from the OPC Foundation Cloud Initiative. And in this conference, Eric Barnstedt from Microsoft talks about aligning all major cloud automation providers into a single reference architecture. I highly recommend to listen into this presentation, which will give you a detailed insight into the shown reference architecture and how it can be deployed out of components either from dedicated cloud providers as well as from open source components. So in my presentation, I just want to highlight 3 components which are instrumental for our integration from the rich and mature on-premise world of OPC via the enterprise cloud into Catena X or any other compliant data space. So The production line time series database that provides rich information, telemetry data, data from MES systems and the like, is a very strong base for data. Second, the information model library that provides an online store of the OPC UA information model, either as a public or as a private instance hosted by a manufacturer. And thirdly, the asset administration shell library, which is an AAS repository implementation of the Digital Twin Consortium. It supports loading AAS models with OPC UA and provides respective RESTful interfaces for consumption. So these three building blocks are really the ones that will, from our perspective, also help us to move into a joint architecture. So how do we bring those two approaches together? At the end, we want to exchange data, of course, data between different participants. So, but let's start from the beginning. Let's start with modeling. So in Catena X, we are modeling with what we call the semantic asset modeling methodology, which is also part of our governance process and our methodology in Catena X. But eventually, after the models are modeled, then they are publicly available in a GitHub repository. And as I said, we strongly believe in open source and openness. So all of our standards, all of our data models are publicly available. And at the end, they are resulting in semantic description in various asset types based on the AS, so asset administration shell standard. What we have done over the last weeks is with an open source converter, we've imported these models from Catena into the UA Cloud library as OPC UA node sets, where they can be adjusted by any OPC UA compliant editor. And from there, they can be made available in the Digital Twin Consortium AAS repository server. And so together with the EDC, you see here on the slide, which is the Eclipse data space component connector, which provides basically this data space protocol implementation. So together with this connector and the Digital Twin registry, we can now communicate with a participant of the Catena X data space. So any asset that I basically have modeled in the DTC AAS repository can now come from the OPC world and can be offered in the EDC catalog. So and once it's in the item is in the catalog, it's being discoverable. So you can discover it now in the data space ecosystem. A potential consumer can search for it. They can search for available offers. Once they find the right offer, then data contracts and usage policies can be negotiated based on the ODL language, as I described earlier. And digital twins can also be discovered with the respective registry components. It's like a telephone book for twins. So the actual data finally can also be retrieved from the actual repositories. Also here, I mean, we're following the Catena X principle of keeping data locally to the data provider. So we believe with this approach, we can start working closer together and building, for example, use cases as we have seen the digital product passport earlier. So wrapping it up, so three thoughts I want to send you away with. First of all, I hope you've seen that Catena X is not replacing a company's existing IT investment. It's rather adding collaborative data exchange capabilities on top of existing investments. Secondly, we believe that OPC and Catena together can provide real business value in horizontal supply chain processes and integrations. And I also want to be transparent that we are starting the journey right now, right? So this is nothing that is completely defined, and we really like to jointly validate this integration approach with you on specific use cases, might be a live DPP, IoT collection pilot, or anything else that you might be interested in. So let's collaborate, let's make it happen. And please do not hesitate to reach out to us for feedback, discussions, or next steps. You see my contact information here. We have colleagues also on various different expert groups that are familiar with the topic. Yeah, reach out and happy to collaborate with you. Thanks a lot for your time.